Okay, on to question 11. A certain investment which fetches a fixed simple interest triples in 9 years. It's becoming 3 times, right? But it's simple interest. So if an investment is tripling, right? If P is becoming 3P, the interest component over here is 2P. So if the principal was 100, it becomes 300. That's because the interest over here is only 200, right? You can always write it as a percentage. And I know it's 200% over here is the interest, right? If 100 was the principal, 200% of this is what you add to get 300, right? So 200% over 9 years. If you understand this logic and the flow, you can divide this and you get 22, 2 by 9, right? And what is the simple interest per annum over here? The closest over here is 22%. See if you can adopt this, right, and understand the flow over here. The whole objective is for you to do things quicker, right? It's not to use the painful techniques and go in for PNR by 100 and it's tripling. P becomes 3P, so 2P is the interest, and applying the formula and all of that. It's a bit of time, still get it, right? Just like that, right? So let's just do it, right, once using that approach. So PNR by 100, right, over here is going to be 2P, right? 2P over here, because if it's tripling the interest component, the formula is for the simple interest, and that's 2P. I know that the N is 9 years. I know the P is getting cancelled over here. So if N is going to be 9, so R over here is going to be what? 200 by 9. So you can do all of that and also get to your 22, 2 by 9, and the closest over here is 22%. The other is for you to observe that 100 is becoming 300, so 200 is the interest. I'm getting 200 of interest, but interest is equal every year, 200 by 9, and directly you can get it in one step as 22, 2 by 9. On to question 12. A certain deposit earning compound interest increased by 1500% in 12 years. Then in 21 years, the deposit becomes how many times the principal? We have to fill in the blank. Okay. Now it increased by 1500%. So P, and in this case, compound interest, the formula is for the amount over here, right? So the longer method, we'll just do that first. P into 1 plus R by 100 whole power 12 equals, if it increased by 15 times, right? 1500% is 15 times. If it increased by 15 times, it became 16 times the principal, right? Amount over here is equal to this. Amount is principal plus interest. Interest is 15 or increases 1500%, 15 times. Then P becomes 16 times P. Okay, so once you write this down, your P gets cancelled, right? 16 over here is nothing but 2 power 4, right? Try to express it that way because we're given an odd number of years, 21 years. So 1 plus R by 100 whole power 12 is 2 power 4. You can divide the powers. 12 by 4 is nothing but 1 plus R by 100 whole cube, right? 12 by 4, that's 2. Now what do I need? I need 21 years. If 3 should become 21, 3 into 7 is 21. Whole power 7 is equal to 2 power 7, right? You need to minimize steps in the exam. 1 plus R by 100 whole power 21 is nothing but 128. All right. So 1 plus R by 100 whole power 21 over here is 128. And you want to know as to what the principal is going to become. So add a P here, add a P here. So P into this is giving you the amount. Amount becomes 128 times principal, right? This is the formula for compound interest. You just add a P over here, you get this, and that's 128 times, right? That becomes the answer over here. Now the same thing, if you want to use another approach, right? I'll just provide it over here. That will be a lot quicker. 1500% more, 15 times more, you should know is 16 times, right? Amount over here for a principal of 1, it becomes 16 or 2 power 4, right? 2 power 4. Let's just be there. 16 equals 2 power 4 with n being 12 years. It means it's doubling and doubling and doubling and doubling. 4 times it's doubling. 4 cycles, all right? It's compounding. So how many times, if it has to double 4 times in 12 years, every 3 years it's doubling, right? 12 by 4. Whatever the power over here, you're going to divide by 4, and you divide by 4. We've covered this in the lessons, right? So you divide by 4 and you get 3. Every 3 years you're doubling. In 21 years, it's 2 power 7, 128. You could just get it directly over here. You could also do this mentally if you're completely clear with the concepts. Else you want to use the formula, you have to go in for something like this. On to question 13. Now, this is a CAT question. Mr. Pinto invests 1/5 of his capital at 6%, 1/3 at 10%, and the remaining at 1%, each rate being simple interest per annum. Fine. Then the minimum number of years required for the cumulative interest income, total interest income, from these investments to equal or exceed his initial capital. All right. We assume the capital over here. The capital over here, I have to find 1/5 of the capital. I should also find 1/3 of the capital. So let's assume the capital over here to be something divisible by 5 and 3. And let's take that to be 1500, right? 5 into 3 is 15. Let's make it a 100 multiple because I have percentages to be applied over here. 1/5 of 1500, all right? 1 by 5 of this is 300. And 1/3 of this is 500, right? And the remaining 3 plus 5 is 8. The remaining is 700, right? The first one is at 6%. The second one over here, 1/3 at 10%. And the last one is at 1%. And what is the interest per year, right? Each year is going to be the same because it's simple interest. 6% of this, 6 threes are 18. That's the advantage when you have a 100 multiple. 10 into 5, because the percentage and 100 take care of each other. 10 into 5 is 50, and 1 into 7 is 7. Add this up and you get 18 plus 7, 25, and a 75 over here. Now, 75 into n, some n, and that n should be number of years when it's going to equal or exceed the initial capital, greater than equal to the initial capital, 1500, right? 75 I can divide over here. 75 2s are 150 and 0. So n is greater than equal to 20. The minimum number of years, what is the minimum value of n if n is greater than equal to 20? That's 20 itself, right? 20 becomes the answer over here. On to question 14. Alex invested his savings in two parts. The simple interest earned on the first part at 15% per annum for 4 years is the same as, okay, the simple interest earned on the second part at 12% per annum for 3 years. Then the percentage of his savings invested in the first part is what? I mean, it's just a straightforward one. P1 into 15%, 15 by 100 into 4, you can just apply that. P2 into 12 by 100 into 3. I mean, you get a question like this, you should take it up. Does it turn up? Yes, once in a while it does. All right. I'm not saying the paper will be filled with this. It was in 2000, somewhere around 2017. CAT 2017 was quite an easy quant paper. You had a lot of questions like this. But even in a tough one, you do get, right? You do get questions like these. You just need to be persistent. P1 by P2 equals, divide this over here and you get a 3, and you have 3 you can divide over here and you get a 3 by 5, right? 3 by 5. P1 is to P2 is 3 by 5. The percentage of a savings invested in the first part. 3 parts in P1 for every 5 parts in P2, for every total being 3 plus 5, 8 parts, right? P1, P2 are the 3 and 5 rupees, then total is 8 rupees. The percentage of savings in the first part, it was 3/8. 3/8 into 100%, or you should be knowing 3 by 8 is 37.5%. You can apply use a calculator for this if you wish, but this is what you'll end up getting. On to question 15. A person invested a total amount of rupees 15 lakhs. A part of it was invested in a fixed deposit, earning 6% annual interest, and the remaining amount was invested in two other deposits in the ratio 2:1, earning annual interest at the rates of 4% and 3% respectively. If the total annual interest income is 76,000, then the amount in rupees lakh, we got to be careful. This was a CAT question as well, right? Invested in the fixed deposit was how much? Fixed deposit is the initial part, right? The rest were in two other deposits. And the amount is in rupees lakhs. I have 76,000 here. I don't want decimals. I will take everything in multiples of 1,000, or I can just stick with in rupees lakh itself, right? So how do we do this? So let us say the ratio is where we start with. Let us say 2x and 1x were into these two deposits, right? The two other deposits. Then in the fixed deposit must have been 15. I'm writing it as lakhs. That's what is asked. 15 minus 2x minus x. So 15 minus 3x is in the fixed deposit. And that is what I'll have to find over here, right? 15 minus 3x is what I'll have to find over here. Need to remember that. Don't find the x value and put it in over here, right? 15 minus 3x is what we have to find over here. This earns at 6%, right? 6 by 100 into 15 minus 3x plus what else? 4% for the 2x, 4 by 100 into 2x plus 3 by 100 into x, right, equals 76,000 in lakhs, right? Write it in lakhs, that is 0.76 lakhs, right? 76,000 is less than 1 lakh, that's 0.76 lakhs. So these hundreds over here, I can take it common and I can throw it to that side, right? If I take the hundreds from here to there, that's going to become a 76. And just the numerators we have to look at. 6 into 15, that's a 90, minus 6 threes are 18x. 4 into 2x, that's 8x, plus 3 into x, 3x. 8 plus 3 is 11. You subtract over here, you get a minus 7x. 90 minus 7x equals 76. Bring the 76 here, take the 7x there, x equals 2. X equals 2, and that's in lakhs. I need to find 15 minus 3x, the fixed deposit. Substitute 2 here, and you get 15 minus 3 2s are 6, and that comes to 9. So 9 is the answer for this question. On to question 16. Arun lent rupees 1 lakh to Azul and Ali, each charging SI and CI, right? Simple interest and compound interest with annual compounding respectively for 4 years. At the end of 4 years, the total amount payable by Azul, okay, the first person, is 1590. The simple interest is 1590 more than Ali at the end of 4 years. Okay. If Ali's accumulated interest at the end of third year, accumulated is given as 33100, then what is the annual interest rate charged by Arun to Azul, the simple interest person? Okay. This is the link over here. Accumulated interest is given to me, and under compound interest, 1 lakh 100,000 is becoming how much? 133,100. Why? Principal plus the accumulated interest of 33,100. 1 lakh is becoming 1,33,100. Straight away, you should know into what? Into 1331, and that is nothing, 1.331, and that is nothing but 1.1 cube. It should ring a bell for you, right? Or you divide this, you get 1.331, right? This is what it is. The moment you're able to write it this way, right, you should realize that in 3 years, if this is happening, into 1 plus r by 100 whole power n, 0.1, r is nothing but 10%, right? R is 10%. Now, at the end of 4 years, what is it becoming for Ali? This is all for Ali, the compound interest, right? The name doesn't matter, compound interest part matters. If n is 4, then it is 1 lakh into 1.4641. How do I know that? I've told you to remember 11 power 4. We have to do a 1.1 power 4 because 1 plus 10 by 100 whole power 4. That's 1.4641. 5 zeros, right? 146410. Okay. Now, at the end of 4 years, total amount payable by Azul, the simple interest person, is 1590 more than this. This is what Azul, right, has to give. That's under simple interest 4 years, and this is the amount. What do we get if we add these up? 590 plus 410 is actually 1000, right? And 1 carry up, and we get 148, and this. Now, this is the amount payable. The principal was 1 lakh. What is the simple interest in 4 years equal to? Simple interest in 4 years is nothing but 48,000, right? 1,48,000 minus 1 lakh. And simple interest in 1 year is going to be 1/4 of this, 12,000. What is 12,000 of 1 lakh? This stage you should know is 12%. That's what is asked. Annual interest rate charged by Arun to Azul, the simple interest. Should mark 12 and go. Or if you want to do it, 12,000 divided by 1 lakh into 100%. The zeros are knocked off and you get 12. 12 is the answer over here. On to question 17. On a 30th birthday, Salma deposits 18,000 in a retirement savings scheme, which earns compound interest. Fine. The scheme is such that the deposit, along with the interest, is paid to the individual at the time of his or her retirement. Fine. The value of the deposit is 36,000 on her 36th birthday. In 6 years, what's happening to it? In 6 years, x over here is becoming 2x. It's doubling, right? Into 2. So the question here is, how much does Salma receive when she retires on her 60th birthday? 60th birthday from 30th birthday, it's 30 years away, right? 30 years is how many 6-year cycles? 5 6-year cycles. Every 6 years, it doubles. This compounding, right? Compound interest. It's not simple interest. It's doubling in 6 years. In 5 such cycles, it becomes 2 power 5 times x. That's it. This is the connect you should know. This question, I'm not going to do it. The p into 1 plus r by 100 whole power 6 and all of that, right? We have done something like this a few questions earlier. Just try it out that way. You'll get the same answer. Start adopting this method if you can. This will get you the speed in the exam. So this is going to give you 32x. X I know is 18,000. X was just written from a reference perspective. The answer over here is 32 times 18,000, right? 32 into 18, 30 18s are 540, 2 18s are 36. 540 plus 36 is 576,000. Option 4 becomes the answer here. On to question 18. Two dinosaurs in Jurassic Park are born today. The first animal is 5 centimeters when born and doubles its height daily. Okay. The second is 1 foot tall and grows 50 centimeters daily. Okay. On the nth day, the first dinosaur's height is more than that of the second for the first time. This is what happens. That's when it happens for the first time. Then n is what? Okay. First animal is 5 centimeters and doubles the height daily. Right? What is happening? At the end of first day, into 2 power 1. At the end of nth day, it's 2 power n. Right? The second one is 1 foot tall and grows 1 foot tall. Hey, this centimeter. Hey, 1 foot is approximately 30 centimeters, right? Got to be careful with that. 1 foot is approximately 30 centimeters. It's 30 centimeters tall and it grows by 50 centimeters daily. All right? N days. It becomes end of nth day. It becomes 30 plus 50n. Nth day, during or whatever, it becomes that for the first time, right? What is the height of height is more than that of the second for the first time, right? The first one is more than this. So just try out the values. We have these over here. Just take some value 6, let's say 5 into 2 power 6, 5 into 64, right? 5 into 2 power 6 is 5 into 64. That's 320, right? And 30 plus 50 into 6, that's 330. It's not working out, right? This is the other way around. This is not working out. 6 is not working out. You probably have to go for the 7th. That's the only thing there. If you want to really try it out, you can multiply this with 2 and you get your 640. And this one is growing by 50 centimeters more plus 50, and that comes to 380. It's greater. So definitely on the 7th day, right? The next day. During the 7th day, the first one goes past the second. So on to question 19. An investment attracts an interest of 8% per annum, compounded annually. The interest rate was doubled in the second year. Okay, the second year, double of 8%, that becomes 16%. What rate of simple interest per annum would have generated the same return over 2 years? Okay. So two ways of doing this. One way of doing this is using the calculator, right? So if you have a calculator over here, all you need to do is 1.08 into 1.16, right? That gives you the multiplication factor on the principal, right? If you get rid of one, that gives you the growth. 0.2528 is the growth. So subtract a 1 over here and you get 0.2528. That's over 2 years. Divide by 2 and you get 12.64%. And that becomes the answer. That's provided you understand this part completely, right? So let me write this down. So P into 1.08 into 1.16, right? 8% more than 1 plus 8 by 100 into 1 plus 16 by 100. It becomes 1.2528 times P, right? This is the amount over here. This is the amount under compound interest, but we want to know the simple interest per annum. So in this case, what is the simple interest equal to, right? If you'd have gotten the same using simple interest, right? What would the simple interest have been? Over 2 years, it would have been the amount 1.2528p minus p, and that comes to 0.2528p, right? So what is the rate of interest over here? This is over 1 year, right? So this is over 2 years. So each year, simple interest per year is equal to 0.2528 by 2, right? And into 100%. I want to convert this to 100 percentage, to a percentage from a decimal, right? So that's it. If you apply this, you'd be getting 12.64%. One way to do it, again, there are better ways in which the same can be explained. We're all looking to understand it conceptually and do it as quick as possible. The approach I would use over here is, I will see. I would say that if 8% and 16% were both under simple interest, then the rate would have been 8% plus 16%, right? Which is 24%. That's it. But the first part is not under simple interest; it's under compound interest. Under compound interest, you get first year's interest of 8% plus the second year's interest of 16% plus interest on interest, right? That is 16% of 8%. Interest on interest. What is 16% of 8%? 16 by 100 into 8%. 16 eights are 128. 128 by this is going to give us 1.28%, right? It comes to 1.28%. Moment you have this, this is over 2 years, right? These are over 2 years. Divide this by 2 and you get your simple interest each year, right? If the same return, what you're getting here, which is, let's add this up and you get your 25.28%. We got 1.2528 there. The same logic, 8 plus 16, 24 plus this 25.28%. If this is simple interest in 2 years, simple interest each year is going to be half of this, 12.64%. And we get option 4 once again. On to question 20. For the same principal amount, the compound interest for 2 years at 5% per annum exceeds the simple interest for 3 years at 3% per annum by rupees 1125. Now, this is a CAT question. The previous wasn't, right? Then the principal amount in rupees is how much? Okay. Now, this question, the way I tackle it is this, right? For the same principal amount, some principal amount, the compound interest for 2 years at 5% per annum. As I told you, if it was simple interest, it's going to be 5 plus 5, right? Each year is 5. 5 plus 5, 10%. But the second year, you'd have had interest on interest, 5% of 5, right? 5% of 5 is going to be 0.25, right? Entire thing as a percentage would come to 10.25%. Or you can use the calculator. And if you want to use the calculator for this particular part, you can do a 1.05 into another 1.05 and you get your 1.1025, which means 0.1025 or 10.25% is the total interest on the principal over 2 years, right? Remember that 10.25%, that's how it works out. Okay. It's easy to apply use the calculator, but you need to interpret it properly. Yeah. 10.25% is what you get. Now, what else is given? This exceeds the simple interest for 3 years at 3% per annum. Simple interest for 3 years at 3% per annum, 3 into 3, 9% is the combined interest. Now, 10.25 is exceeding 9 by 1.25%, right? 10.25% minus 9% is equal to this. Yeah. Now, 1.25% of the principal equals 1125, right? Now, if you want, you bring in the calculator. Or however you want to do it, right? So what do you get? 1.25%, let's say you want to use the calculator, 0.0125, right? By 100, you move it by 2 decimals and bring back your calculator. And all you need to do is 1125. Your principal is 1125 divided by 0.0125 equals what? And you get your 90,000. One small difference here, the way I would do it is, again, I tend to avoid using a calculator. I'll leave it to you if you wish to, right? What's the principal amount going to be? 100% of principal is where we're done with it, right? So 1.25 into what? I would know it's 80, right? If you know that part, it's going to be slightly easier. So into 80 over here helps us. Again, break it down as into 10 and into 8. 8,000 and 125 into 8. If you know those well, you'll know that's 9,000 into a 10 and a 90,000. Again, I'll leave that to you. If you're completely there with mental math, you can use this. If not, you can just rely on a calculator over here.